Good day, everyone. Today, I'll be discussing the introduction to the Webster method. So, what is Webster method? Webster method is a mathematical procedure used to distribute a fixed number of seats of representatives among groups according to their population. It is commonly applied in apportionment problems, particularly in government systems where representation must be divided fairly among states or districts. The method was introduced by Daniel Webster in the 19th century during discussions about how seats in the United States House of Representatives should be allocated among the states after each national census. At that time, different methods were proposed to solve the issue of fair representation, and Webster suggested a system that would produce balanced results between large and small states. His method later became one of the well-known divisor methods used in apportionment. So why is the Webster method important? It is important because this process helps ensure a fair and balanced distribution of the representation among different populations.
Webster's method of apportionment is a divisor-based system used to distribute seats among states or groups based on population. But how does it work? First, find a divisor. Start with a modified divisor, roughly the total population divided by total states. Second, calculate quotas. Divide each state's population by that divisor to get a quota. And then lastly, round normally. Round each quota to the nearest whole number. And this will be furtherly elaborated to the next slides.
Next is definition of terms. The first definition of terms is apportion. Apportion means to divide or distribute something fairly among different groups. Like for example, seats in a government can be apportioned based on the population of each region. In simple words, apportion means sharing something fairly among groups usually based on their population. Next is population. Population refers to the total number of people living in a certain area, such as a city, province, or country. This means the number of people living in a place. Next is divisor. Divisor is the number used to divide the population to determine how many representatives or seats each group should receive. This means a number used to divide the population to know how many seats each group should get. Next is quota. Quota is the result obtained when the population is divided by the divisor. It shows the number of seats assigned to a group before rounding. This means that the answer we get after dividing the population by the divisor. Next is rounding rules. Rounding rules are the guidelines used to round a quota into a whole number because seats cannot be given in decimals. This means rules used to change decimal number into whole numbers. Next is total seats. Total seats refer to the overall number of seats available that will distributed among the groups or regions. This mean this means the total number of seats that will be shared among all groups. And lastly, adjustment of divisor. Adjustment of divisor means changing the divisor when the total seats distributed do not match the required number of seats. This means we change the divisor or if the total seats given are more or less than the required number. So, understanding these terms help us know how seats or representation are fairly divided based on population. Thank you.
Steps or procedures of the Webster method. Steps or procedures are important in solving the problems using the Webster method. First, it ensures fair distribution of seats because the method follows a specific rule in assigning seats based on population. Second, it provides a clear systematic process, which means we follow an organized order steps when solving the problem. Third, the procedure helps avoid calculation errors, since we follow the correct process from finding the divisor up to rounding the quotas. And lastly, it makes the solution easier to understand, because each step shows how the final answer was obtained. By following the proper procedure, we can avoid errors and make the solution easier to understand. This is why the Webster method follows specific steps when solving the apportionment problems. So the first step is to calculate the standard divisor. This is done by dividing the total population of all states by the total number of seats that need to be distributed. The standard divisor helps determine how many people are represented by one seat. The second step is to determine the standard quotas. To do this, we divide the population of each state by the standard divisor. The result is called the quota, which show the estimated number of seats each state should receive based on the population. The third step is to round the quotas. In the Webster method, each quota is rounded to the nearest whole number. If the decimal is 0.5 or higher, we round up, and if it is less than 0.5, we round down. The fourth step is to check the total number of seats. We add all the rounded quotas to see if the total is equal to the required number of seats that need to be distributed. Step 5. Adjust the divisor if necessary. If the total number of seats is not unequal to the required number, we move to the next step, which is adjusting the divisor if the total seats are too high. We increase the divisor. If the total seats are too low, we decrease the divisor. And lastly, recalculate. We recalculate the quotas using the new divisor and round them again. This process is repeated until the total number of seats exactly matches the required number of seats to be distributed. So those are the steps or procedures in solving the problems using the Webster method. By following these steps, calculating the standard divisor, determining the quotas, rounding the quotas, checking the total seats, and adjusting the divisor if necessary, we can distribute the seats fairly and accurately based on the population. Now that we understand the procedure, we will see how these steps are applied on the actual problem. To demonstrate this, I will now pass it to the next reporter who will discuss the sample problem and its solution using the Webster method.
So let's proceed to our sample problems. So our sample problems is a country needs to distribute 10 seats in parliament among 4 regions based on this population. So now there is a table, region A, B, C, D, and sa ilang population is sa A is 24,000, sa B is 18,000, sa C is 15,000, and sa D is 9,000. So amo gi-use ang Webster method to determine how many seats each region receives. So let's proceed sa solution. So amo siya is step by step unsaon siya pag-solve. So step 1. So step 1 is ato i-find ang total population, which is ato siya i-add tanan ang A, B, C, D. So ato i-add ang 24,000 plus 18,000 plus 15,000 plus 9,000 is equals to 66,000. Then ngano ato siya gitotal tanan population? To calculate the standard of divisor, which tells us how many people should correspond to one seat. Next is step 2. Find the standard divisor. So natay formula nga gisunod ani. So ang formula is standard divisor equals total population over total seats. So SD equals 66,000, which is kato atong na total all, divided by 10 equals 6,000. Meaning, one seat represents about 6,600 people. And next is step 3, which is Miano will explain this.
Third step, we have to find the quota of each region. So we all know that the formula is quota equals population divided by standard divisor. So SD equals 66,000 divided by 66,000 divided by 10, so it's equals to 6,600. Now for region A, the population is 24,000, so we have to divide it by 6,600, so the total quota is 3.64. For region B, it's 18,000, so we have to divide it by 6,600, so the quota is 2.73. For region C, it's 15,000 divided by 6,600, so the quota is 2.27. For region D, we have to divide it 9,000 divided by 6,600, so the total quota is 1.36. So why do we have to do this? The quota tells us the exact proportional share of seats of each region that deserves before rounding. Now, the next step is to apply the Webster rounder rule. In the Webster method, round the nearest whole number. So we all know how to round off naman, diba? So, region A, the quota is 3.64, so the total rounded seats are 4. For region B, the quota is 2.73, so the total rounded seats are 3. For region C, the quota is 2.27, so the total rounded seats are 2. And lastly, region D, the quota is 1.36, so the total rounded seats is only 1. For the next step, or the last step, check the total seats. So, since we're checking the total seats, so we have to add everything. 4 plus 3 plus 2 plus 1. So it's equals to 10. The total equals the required 10 seats, so no modified divisors needed. So, the final answer is for region A has 4 seats, region B has 3, region C has 2, and lastly region D has only 1. For the next slide, the conclusion will be reported by Ragazza.
To conclude or summarize everything, the Webster method is a fair and balanced way of distributing a fixed number of seats or resources among groups based on their proportions, such as population. It works by dividing each group's population by a common divisor and rounding the results to the nearest whole number, which helps reduce bias that may favor either larger or smaller groups, because it uses standard rounding rather than always rounding up or down. The method generally produces allocations that are closest to the true proportional shares. Overall, the Webster method is considered an effective and inequitable approach to apportionment when the goal is to achieve representation that closely reflects the actual proportions of each group. So to better understand everything, it can be read in the introduction, description, definition, sample problems, and the steps and procedures.